We're going to change gears now and start talking about the gas laws. Now, another term for the gas laws is the equations of state. And the equations of state discuss the relationship between the volume, pressure, and temperature and mass of a gas. So let's start off with the first two, volume and pressure. So if we were to actually take a gas and keep all the other variables the same, just vary the volume and the pressure, what you would see is that as you increase the volume, your pressure would decrease exponentially. This was discovered in the 1600s by Robert Boyle. And Boyle's law states that the volume of a given amount of gas is inversely proportional to the pressure as long as the temperature is constant. In other words, volume is proportional to 1 over P. Another way to write this mathematically would be to take pressure and multiply that on both sides, and that is the pressure times the volume would be a constant. Okay, the second of the laws is Charles' law. In Charles' law, the volume is linearly proportional to the temperature. So in other words, if you double the temperature, you're going to double the volume as well. Now, this is true as long as the temperature is slightly above the condensation point and the pressure is held constant. In other words, it's known to work in this range for different substances. For water specifically, it works best right around here. Now, there's something really interesting about this. It is a linear relationship. And the linear relationship is slightly different from one substance to another, but no matter what, if you take that line and you extrapolate that line all the way down until you reach a volume of 0, it always comes to exactly the same point. In other words, the temperature at which a volume would drop to 0 would be negative 273 degrees Celsius. So we call this absolute zero. Now, absolute zero is the Kelvin temperature scale, which you can see down here, is a temperature scale based on this point of absolute zero. This point at which the volume would equal 0, the pressure would also equal 0. I'll just say that right now. The energy of a substance would equal 0. This is like the absolute 0 point of everything. That will be 0 for the Kelvin scale. And so the Kelvin scale starts at 0K, or absolute 0, but it's the same as the Celsius scale from there on. So in other words, an increase in 10 degrees Celsius would be an increase in 10 Kelvin. So since the absolute 0 is negative 273.15 degrees Celsius, and an increment in Celsius would be an increment in Kelvin, they'd be the same. An increment going from absolute 0 to the freezing point of water is a change of 273.15 Kelvin. Therefore, the freezing point of water is 273.15 Kelvin. So, and then an increase of another 100 degrees gets us to the boiling point of water, and so we increase by 100 degrees. In other words, 100 Kelvin. So this is just an interesting table that relates boiling point of water, freezing point of water, and absolute 0 in all three of the temperature scales that we have talked about. Now, I want to make this important point. Notice how in Fahrenheit we have degrees Fahrenheit. In Celsius we have degrees Celsius. But in Kelvin, there is no degree symbol. That is a standard point that's made here when we talk about the Kelvin scale. we're not talking about degrees. We're talking about units. There is an actual 0 point. When you talk about degrees, you're talking increments. Kelvin, no, we have an actual 0 point. That is absolute zero. And so we are just using the unit itself. We don't need a degree symbol there. And so we've got our 3 temperature scales where we can convert from Celsius to Fahrenheit. We saw that in a previous video. And now we have a temperature scale in Kelvin. A temperature in Kelvin would equal the temperature in Celsius plus 273.15. All of this came from Charles' law, which is that the volume is proportional to temperature. There's another law that's very similar to Charles' law, and that is Gay-Lussac's law, which states that when a volume is proportional to, when the volume is held constant, the pressure is directly proportional to the temperature. If you have a gas in a rigid box that will not change shape despite the temperature, then you double the temperature inside the box, then you're going to double the pressure inside that box as well. So here are the 3 gas laws that we've been talking about. Boyle's law, which is that the product of pressure times volume is a constant, or, as we said before, pressure is inversely proportional to pressure. Charles' law, which says that volume is proportional to temperature, and Gay-Lussac's law, which is that pressure is proportional to temperature. And if you combine all 3 of these together, we find that pressure times volume is going to equal some constant times temperature. And in the next video, we'll talk more about what is involved in this constant.